Good morning viewers, welcome to my YouTube videos on high physics logs.
Hello, good morning students. Today I would like to discuss the derivation for the refractive index of a prism. Generally, refractive index can be represented by the symbol of mu. Here I am considering a prism. So generally the prism will be looking like this. This is the 3D of the prism. Here from this prism I am considering the principal section. This is central part, that is one of the layer of the prism. This can be known as principal section of the prism. Here this principal section I am considering here like this, named as ABC. ABC, this is the equilateral prism. You can say AB and AC are the two sides of the prism, and BC is the base of the prism. Base can be represented by these lines. So here consider ABC is the principal section of prism. Okay, AB and AC are the sides. AB, AC are sides. BC is base of prism. See, let us say a ray AB, the ABC, on the AB just above half a ray will be incident. Let us say like this. This is named as PQ ray. This is the incident ray. Whenever the incident ray falls on the side AB, what happened? It will be refracted into the prism. That means it will passing through the prism and emergent in this direction. Emergent. So this is named as PQ is the incident ray, QR is the refracted ray, RS is the emergent ray. That's all. Now this is, if it is an equilateral prism, then angle should be 60 degrees. Here A is called the angle of prism. Here A is called angle of prism. Now PQ is incident ray, QR is refracted ray, and RS is emergent ray. Let us see. Now how can you know the angle of incidence, angle of emergent? For this you have to draw a normal here. Say for example, here you can draw the normal. Generally normal can be drawn with the what you can say, compass. I am drawing manually here. This is the normal. Yeah, this is the normal. Let us see. This normal, from normal to this side, this you can call as angle of incidence, I. Whereas this you can call as first surface refraction, R1. Again, if you want to know the angle of emergent, same you have to draw a normal here like this. Say this is N1 normal, this is N2 normal. From the normal to this point, this you can call as angle of emergent I2. This is I1, this is I2, this is R2, angle of refraction. Okay, here I am getting two angle of incidences, one angle of incidence I1, angle of emergent I2, R1 and R2 are the angles of refractions. Got it? Now PQRS is the ray. This meeting point you can name as PQRS and then T. Okay. Now from this, here I1 and I2 are angles of incident and emergent, right? Here R1 and R2 are angles of refractions. Okay, now from this triangle QTR, from triangle QTR, this will be like a triangle. T is the angle here. Okay, now as we know that sum of the angles in a triangle is 180 degrees, obviously. That means from the diagram I can write R1 plus R2 plus T, that is angle T, which is equal to 180 degrees. You can put angle T 180 degrees, keep in the equation 1. Let us next from this quadrilateral AQTR. So from this quadrilateral, what you will get here? That is equation 1. From quadrilateral AQTR, from this triangle, from this quadrilateral, sum of the angles is equal to 360 degrees as usual. That is angle A plus angle Q plus angle T plus angle R is equal to 360 degrees. Angle A, simply you can write A. Angle Q 90 degrees. Angle T, simply T, plus angle R 90 degrees, that is equal to 360. From this equation we will get A plus T is equal to 360, 90, 90, 180, 180 going outside, that side 360 minus 180 as usual 180 degrees. Let it be equation 2. Now from these equations 1 and 2, what do you observe? 180, 180, then equating the left side. So R1 plus R2 plus T is equal to A plus T. T gets cancelled. From this you will get R1 plus R2 is equal to A. This is important formula. So let it be equation number 3. Now up to this, okay, I am getting the relations between the angles of prism and angle of refractions. That is R1 plus R2 is equal to 2. Next, in the absence of the prism, what happened? Sorry, in the absence of the prism, what happened? So the light ray generally goes in the straight way. In the absence of the prism, the light ray will go in the straight way. Okay. Now, if you extend this emergent ray like this, here P, Q, R, S, T, U, let us say, this extension will get the angle of deviation, which we can call as angle of deviation D. Let us see. Okay, angle of deviation is D. So this path will be PQU path. So we can write here, in absence of prism, the light ray goes PQU path. So by extending emergent ray, we get angle of deviation, that is angle D. This is the angle of deviation D. Now again you can use this triangle. There is a triangle here, I can draw it clearly. Okay, this is the extension one, this one and this one. Okay, this is angle D. This is the U point, this is the Q point, this is the R point. Here as we know that this angle is R1, this angle is R2. So what about this angle? I need this angle. So generally the it will be like this. If it is a straight line, this angle is 180 degrees, you can say. From this 180 degrees, D will be gone. Then remaining part of this angle, how can you write here? 180 minus D. This is the angle. 180 minus D. Now, what about this one? So as we know that these two angles are same. This is I1, this is also I1. Now R1 will be gone. Then what you will get here? I1 minus R1. This is one angle. Here what about this one? I2 minus R2. This is the one angle. I1 minus R1, I2 minus R2. So why? Because this angle, this will be looking like this. Okay, again we can write, better to write here. Like this, like this. This is I1, this is R1. So what about this one? Remaining this one, this part is, oh sorry, yeah. This is I1, this is I1 also. This is R1 gone. How much will we get? I1 minus R1. So I1 minus R1. This is also same, similar to this. This part is also same thing. I2, this total will be I2. I am removing R2. That means this angle should be I2 minus R2. Now from this triangle, from triangle QUR, sum of the angles in a triangle is equal to 180 degrees as usual. That means what are the angles here? I1 minus R1 plus I2 minus R2 plus 180 minus D is equal to 180 degrees. Now simplification is I1 plus I2 minus R1 plus R2 is equal to 180 gone. That will be, that side D, small d will be there. Or simply, but from this equation 3, R1 plus R2 is equal to A. That means from 3, simply I can write I1 plus I2 is minus A plus is equal to D. Or simply I1 plus I2 is equal to A plus D. Keep in mind, this is equation number 4. Now these are the equations we require. We want to derive this refractive index of the prism. Okay, to be clear. Now from these equations 3, that is R1 plus R2 is equal to A, I1 plus I2 is equal to A plus D. Now from the diagram, as we say that if you plot a graph between I and D, which we can call as ID curve. So say for example, if it is the prism, this is the angle of incidence, this is the I value, this is the D value. So I value will be changing, D value also changing. How the changes will be there? That can be drawn from the graph. If by plotting a graph between I on the x-axis, D on the y-axis. If angle of incidence, say for example, you can draw roughly 30 degrees I value and a D value 35, I value 30, 35, 40, 45, 50, 55 like this. Angles will be gradually increasing. What happened to the D value? So D value will be, say for example, at the 30 degrees, it will be around 51. Let us say at 35, it will be 49. At 40, it will be around 48. At 45, it will be 49. At 50, that is, it will be 51. At 55, it will be 53, like this. Let us see. That means what happened here is, if I value increases, D value decreases to a particular value and then increases. That means here this at this point at 48 degrees, angle will be minimum. So the graph will be like this. So graph will be decreasing at a particular point, constant, and then increasing. So where you will get the minimum value at this point, which we can call as the angle of minimum deviation. So at this point, say for example, the D angle of deviation is nothing but equal to dm. Dm stands for angle of minimum deviation. At this angle of minimum deviation, I1 value, I2 value should be equal. Similarly, refractions value also equal. This is the condition for the angle of minimum deviation. So you can write here at angle of minimum deviation position small d is equal to dm and I1 is equal to I2 is equal to I and R1 is equal to R2 is equal to R. Now substituting in 3 and 4, what you will get? R plus R is equal to A, or simply R is equal to A by 2. Keep in mind, wherever from this I plus I is equal to A plus dm, or simply I is equal to A plus dm by 2. This is the I value, R value. But according to the Snell's law, from Snell's law, we know that refractive index mu is equal to sine I by sine R. Simply substituting here, you will get refractive index of prism, mu of prism, mu is equal to sine of A plus I means sine dm by 2 by sine A by 2. This is the derivation for the refractive index of the prism, that is mu is equal to sin A plus dm by 2 by sin A by 2. Here refractive index of the prism depends on angle of minimum deviation and also angle of prism. So for small angled prism, for the continuation, for the competitive point of view, for small angled prism, we know that theta is small. That means sin theta is equal to theta. That is dm is equal to, you can say simply, delta. So substituting, what you will get? Mu is equal to sine A plus delta by 2, or simply A plus delta by 2 by sine A by 2. Sine will be very small. Sine neglecting this, what you will get? Mu is equal to A plus delta by 2 by A by 2. 2 to cancel, to the cross multiplication, what you will get? Mu A is equal to A plus delta, or simply delta is equal to mu A minus A, or delta is equal to A common mu minus 1. This is the formula for the small angled prism. If the question is given here, refractive index of some value is given, say for example, the example question is also there. You can write example question. If angle of small angled prism is 4 degrees centigrade and we can say minimum deviation is angle of minimum deviation is 2.4. Find the refractive index. Yeah. So substituting this, you will get 2.4 is equal to 4 into mu minus 1. 4 0.6 times, that is equal to mu is equal to simply minus 1 going that side, 1 plus 0.6, that is 1.6. So in this way some small problems will be there. Okay, this is about the angle of prism derivation part. Thank you for watching.